Opus. General description. Opus is a user-centric platform for telecom-oriented, user-generated services that provides users with the tools they need to create new services. Opus stands for Open Platform for User-Centric Service Creation and Execution. One of the main characteristics of Opus is that it merges Internet and telco services. Opus gives users the chance to create services themselves simply by composing a set of base services. These base services can be running on the Internet, just like the email and syndication feeds. Other base services will be running in telecommunications networks such as location, call control, presence, or messaging services. In Opus, the access to the network by users is done in a safe manner. Operators don't have to be afraid of malicious users accessing their networks. Obviously, Opus doesn't emerge from nothing. It feeds from many other approaches. We take ideas from service creation approaches that are on the Internet, such as Yahoo Pipes or Google API. The Telco 2.0 ideas of the BT 21st Century platform are also an important reference. The new widget approach has influenced Opus. Opus also feeds from the idea of user-generated contents. In this sense, the Time magazine nominated you as Person of the Year 2007, highlighting the increasing importance of the end user and the Web 2.0 paradigm. Opus adapts all these trends and combines them with other initiatives derived from existing standards, open source communities and other European projects. All of this together gives us the necessary background to achieve three of the main objectives of Opus: the creation of services, the rapid user-centric service lifecycle management, and the sharing of user-centric services. But what is the technological background required to achieve all this? Two things. Firstly, a platform that allows users to take an active part in the service lifecycle. Secondly, the design of efficient mechanisms to manage events received from the platform or generated from the user's interaction with the platform. Opus Lifecycle. Users can take part in the lifecycle of the services they have created with Opus. In traditional service lifecycles, four big states are usually considered: creation, deployment, operation, and withdrawal. Users are not directly involved in any of these states. The operator is the only one that is able to decide what to create or when to activate or withdraw the services. This is not the case of Opus. In Opus, users are involved in the main states of the service lifecycle. Firstly, users take an active part in what is traditionally called implementation and testing steps. In Opus, these steps correspond to composition tasks. Users don't have to implement anything, they just have to combine pieces. Something similar happens with the analysis and design states. Users are not conscious that they are carrying them out. When the composition finishes, the users trigger an event that deploys the service in the platform. This is done very easily just by pushing a button that deploys the service. Users are also involved in the operational state. Users can include scheduling information that is used to determine the activation or passivation time of the service. If the users decide to, they can also withdraw the service from the platform. Logically, users are the only ones allowed to withdraw those services created by them. The Opus platform fulfills the three main requirements in the context of user-centric service creation and delivery. 1. It provides users with a set of easy-to-use tools that can be used to create, manage, discover, subscribe, and customize services. 2. Users can start running the services they have created, as well as subscribing to services created by other people. 3. It includes automatic management tasks that are carried out with minimum user or operator intervention. Opus Architecture. The Opus architecture can be divided into three big blocks. The core of the platform is the service execution environment, which orchestrates the base services that make up the mashup. Base services are exposed to the platform by using a web service interface described in WSDL. No matter what the implementation of the base service is, we can have Jane Slee, Java Enterprise Edition services, and so on. The logic of the service flow is described in BPEL. This description orchestrates the base service invocations and the events that are received from the network. The portal is the interface between the user and the platform. It provides simple tools to create new mashups and share them afterwards. Opus provides a friendly graphic user interface. Services can be made up by using an AJAX-enabled browser on a desktop computer. In mobile devices, services can be created by installing a local application. The portal also allows users to discover and subscribe to new services, manage their profiles, customize their mashups, and share mashup-related information with other users. The rest of the elements can be included in the operations support system. It bridges the portal and the execution environment to carry out the deployment, scheduling, and provisioning activities. An advertiser module manages mashup recommendations, and a service repository stores both the description of the services and the base services. Security features are also managed here by integrating a AAA module with a diameter service. Both elements leverage in the user profile repository to retrieve information about the subscribers. Additionally, the context user feed compiles user context information. The running of services is adapted according to the context information retrieved from the users. Opus Events Logic. Events rule the behavior of a service in the telco world. During a phone call, the communication is established with an event generated at the destination when the phone is picked up. In Opus, the service execution environment handles all the events that are received from the rest of the modules. The Lifecycle Manager launches events according to the service logic. The Context Awareness module adapts the logic according to events received from the user's context. However, events are not only used to rule the service logic. They are also used to manage the service triggering. When a user subscribes to a service, the platform registers this subscription event in the execution environment. Then the service can be invoked when conditions apply. For example, sending an SMS with the word location to a premium number would start the service called location. The event generated after sending the SMS is forwarded through the network and the execution environment until it reaches the service that is listening out for it. Opus Service Description. In Opus, each service is characterized by a unique service description. This service description is a document generated at the time of creation which describes each aspect of the service. A master document describes the general aspects of the service, that is, the name, the creator of the service, a description of what the service does, etc. The specific aspects of the service are described in different facets that are included in the service description. This model is easily extensible as new facets can be added where necessary. The descriptions of the facets are stored in different documents. The facets and the master document are linked to the service they are describing. We currently consider facets that describe the logic of the service, the graphical representation of the composition, semantic information that describes the service, deployment activities that need to be carried out for this service, the scheduling information for the activation of the service, and the accounting plan that has to be applied in the service. This service description model is suitable for describing both composed services and base services. The only difference is that a composed service description may include facets that a base service description will not, and vice versa. The format used for this service description is a simple XML document. The model allows each facet to be described in any XML language. This makes it compatible with current specifications such as BPEL for the logic, OWL for the semantic, or SPML for the provisioning. However, custom languages have been created to describe some facets. This was the case in a graphical service description.